The future of human spaceflight is bright, and human-crewed missions to the Moon, Mars, and beyond are within our reach. However, spaceflight is a dangerous endeavor. In emergency situations, radio signals can be used as a method of direct communication or as a beacon to locate missing humans or critical equipment. As humans travel further into space, the bandwidth and round-trip speed of radio communications to Earth becomes extremely limited. Radio signals are typically sampled at rates in the millions per second. We need the ability to process radio signals and identify patterns using edge compute located throughout our solar system and send only the most critical information back to Earth.
Our hackathon demonstrates that you don't need highly specified hardware to process signal data. A general purpose compute like HP Spaceborne Computer 2 on board the ISS is perfect for the job. We have a team with people from multiple technical backgrounds and nationalities. Individuals that love space, some with background in physics, data analysts, project management, coding, infrastructure, and networking. But what really brought the group together is the idea to empower every person and every organization on the planet to achieve more in order to discover and expand knowledge for the benefit of humanity.
The space system, written in Python and containerized using Docker, generates simulated IQ radio signals, performs discrete Fourier transforms, and identifies the important signals amongst the sea of radio noise. It then logs the start time, peak time, end time, frequency, and peak power of these signals in a data storage format called Apache Parquet, chosen because it results in a file around 5 times smaller than the equivalent CSV file, and 2 times smaller than a gzip compressed CSV file. The data is then sent from space to ground using the provided ISS ground station simulator, and then to Azure storage using AZ copy. Once on the ground, a logic app notifies operators of the arrival of new data by sending an email, and by a physical signal, in our case, a light. This kicks off our data factory pipeline. This pipeline extracts the Parquet file into CSV format. Then an Azure function adds the International Space Station's position by calling the NASA Satellite Situation Center web API. The final data is stored in SQL Server, where we use the data to analyze possible sources of the signal. Power BI is used to visualize reports, and an Azure web app publishes findings using embedded reports and 3D visualizations. We believe this project demonstrates the massive potential of performing digital signal processing on radio data using general-purpose compute in space that could help not just in advanced scientific purposes, but for search and rescue missions and other emergency situations our astronauts will inevitably encounter as they travel further and further from Earth. Thank you.